Okay, let us discuss this problem. So what you have to do is, in this case, you have to write down the product. So let us first copy this one. So I have to cover this one so that you can see the solution part. Okay, so let us copy this one first and then we will write. So let us say, just copy this one. You have been given an alkene and you have been given an alkyl halide and you have been given AlCl3 and you have to write all the possible products. So there are many products that is possible. You can have a substitution product, you can have elimination product. You have to write all possible product. I will give you a hint what AlCl3 can do. Did you remember Friedel-Crafts alkylation reaction? In Friedel-Crafts alkylation reaction, what AlCl3 does? AlCl3 basically generates a carbocation. So in the same way, you generate a carbocation here, and then alkene. What alkene can do? Alkene can act as a nucleophile. So take alkene as a nucleophile, attack the alkene, you will get a carbocation. Now once you get a carbocation, there are many possibilities. A carbocation can be attacked by a nucleophile, so you get one product by nucleophile. Another possibility is carbocation can rearrange, so you rearrange if possible. After rearrangement can be attacked, it can be attacked, so you will get another product. After rearrangement, Cl- can attack, or it can do elimination. Carbocation can lose one H plus. So if you lose one H plus, you will get an alkene. So you see, we have given in all hints. So first case, you generate a carbocation. After generating the carbocation, attack a nucleophile. After attacking the nucleophile, what you will have? You will have a carbocation. After attacking the nucleophile, that is alkene as a nucleophile, you will get a carbocation. That carbocation can either do E1 or it can do SN1. So let us write at least 4 products. Or basically in this case there are 6 possible products. So let us write as much as you can. Let me wait for 1 minute. Okay, let us go for the solution. Anybody have done something? Not yet. Okay, let us do. Alkene is an important chapter. In every exam you will find some questions is coming from alkene. Because you can attack a nucleophile of attack of a nucleophile, you only learn in alkene chapter. Okay, let us see the solution. What we can do is, so let us discuss the first step. I have this Cl. This Cl can give electron to AlCl3 because AlCl3 is a Lewis acid. This can take electron, so this Cl electron give electron to aluminum and this bond breaks. As soon as this bond breaks, you will have a carbocation that is generated. So you see, if you break this bond, you will have CH3C plus CH3CH2. So you are getting the same thing, you are generating a carbocation. And once you have generated a carbocation, what the next step can happen is, this alkene can further attack on this carbocation. If this alkene attacks on this carbocation, there is a bond formation. Are you getting? Now we have two possibilities. I can generate a carbocation from this side, or I can generate a carbocation from this side. This will be more stable, this will be less stable. So let us say, if I do something like that, I will have a carbocation generated here. So let me write. So this will be minor, so I am leaving that one. This will be the major carbocation. So let us say this is a major carbocation, 2 degree carbocation. Now in the next case, what can I do is, I can do a hydride shift. So if I shift a hydrogen here, or if I shift a hydrogen here, so what you will have? If I shift a hydrogen here, so let me write here. So this molecule can do 2 things. If this shifts a hydrogen, so you will have CH plus here. In this case, you are not getting any benefit because 2 degree and here also 2 degree. But if you do one more time methyl shift, now you are getting a benefit. If you do methyl shift, you will have something like this. Now this is at 3 degree. 1, 2, 3. So we have to do 2 times shift. One time hydrogen shift, another time methyl shift. So let us do this one and then we'll discuss. So you copy from here to here. So you have a hydride shift, you copy this step, you will get this one. You do one methyl shift, you copy this step. So up to here you copy. So you have to copy up to this step. Are you getting? So from here, so you copy from here, hydrogen shift to here, and then from here to here. Now let us see what are the product that is possible. If you see this compound, this carbocation, if it loses H plus, it will generate alkene. So this is one product. That is the product number 2. If Cl minus attacks on this carbocation, I will get this product. So the first attack is attack of Cl minus. I am getting this product. That is the SN1. So this is product of SN1. Now in this case, if it loses H plus, that is the product of E1. I am getting an alkene. Now, so carbocation can go via SN1, it can go via E1, it can go via shift, that is rearrangement. So this is hydrogen shift. So if it does shift, you will have this carbocation. Now again, you have two possibilities. It can be either attacked by a nucleophile, that is Cl minus. So again, this is SN1, or it can lose H plus. If it is loses H plus, I am going to get the same compound, this one 2. So I am not writing here. Now this case, again I can do the same thing. If it loses H plus, I will have a double bond here. So if it loses H plus, it will have a double bond. Now this compound will exist basically cis and trans, because two methyl group same side, it can be opposite side. So this will exist in a cis and trans. Now this carbocation will be attacked by a Cl minus, so I will get this product. So this is a basically even product, and this is my SN1 product. Now you copy. So we have discussed all the thing. You can copy now. So basically I am holding the camera so that you can see the full page. In my adjustment I cannot see the full page, and that's why you have to make another adjustment for the camera. Are you getting or not? So I think most of you have written. No? Not yet? Okay, let us wait for one more minute. So you see, what we are doing is we are first generating a carbocation, and once we have generated the carbocation, so it can go either rearrangement, it can do elimination, or it can do substitution, SN1. So we can write all the possible product. If I do substitution, what will be the product? If I do elimination, what will be the product? If I do basically rearrangement and methyl shift, hydride shift, what will be the product? So you have to see in this case what we have learned. We have learned what are the reactions of carbocation. Basically a carbocation can do three things. Either it can rearrange, that's the first thing, or it can be attacked by a nucleophile, the second thing, by SN1 reaction, or it can go elimination, that is E1 reaction. So carbocation has three possibilities: possibility of rearrangement, possibility of substitution, possibility of elimination. So we have discussed all these three possibilities in one reaction, and AlCl3 basically in this reaction you see here, AlCl3 is acting as a catalyst. So this helps to generate a carbocation. Sometimes SBF5 is also used to generate a carbocation. If you have alcohol here, not chloride. If you have OH group, then in that case H plus is used to generate a carbocation. In all the cases, reaction will be same. Only thing will be, in one case you will have OH and then you have to take H plus. In another case you can have alkyl halide. You have to take the Lewis acid AlCl3 BF3 ZnCl2. You can take another acid AlCl3 LBr3 when you can take. So this is the reaction of carbocation. We will go for the next problem. So this is a quite interesting problem. You have to write all possible products. Cis trans you have to also consider. You have to consider rearrangement product. You have to consider elimination product. So first you have to see how many carbocation I can generate. And once you know the carbocation generated, that is this one. Once you know this carbocation has been generated, this carbocation, and after hydroxide this carbocation, and after methyl this carbocation. So now you know the 3 carbocation. Now you know the reaction, because all those 3 carbocation can do. It can go elimination or it can go substitution. So you have to look for carbocation, how many carbocation you are getting. That is the important trick. That is the important part. Okay, we'll go for the next problem.